Hello everyone, welcome to Royal Palace online classes. Today let us discuss some synopsis points of laws of motion. Laws of motion starts with Newton's first law. Newton's first law states that every body will be in its state of rest or of uniform motion in a straight line until and unless acted upon by external force. Straight line until and unless acted upon by external force. What he says is, body will be at rest until you apply force. Body will be in uniform motion until you apply force. So it defines force. Force is the cause for the motion. Force is a physical quantity which changes or tends to change the state of rest. Next, it may change the uniform motion of a body. It may change the uniform motion of a body. It may change or tends to change. It may change the direction of a body. To change all these things, we require force. And first law also defines one of the important property of a body, that is inertia. Inertia is the inherent property of the body by virtue of which it opposes the change in its state of rest, reluctance to change, the opposition for any change. It may oppose the change of rest, it may oppose the uniform motion, it may oppose the change in direction. Body which is at rest want to be at rest only. Body which is in uniform motion want to be at uniform motion only until and unless you apply some force. These two are interrelated. It is the inherent property. That means body which is at rest want to be at rest only. Body which is in uniform motion want to be in uniform motion only. Body which is in single direction want to be in that direction only until and unless we apply some external force. Inertia is of three types. One is inertia at rest. Inertia at rest states that body which is at rest want to be at rest only. For this you can take one small example which you already studied in lower classes. There is a glass beaker, on that you placed a cardboard. On that cardboard you kept one marble or one small ball. If you apply a small force on cardboard at high speed, just pull it out, then what happens? The marble will fall into the, when you take out the cardboard, the marble will fall into the beaker. That means the marble which is at rest want to be at rest only because the force is applied on cardboard but not on the marble. So the body which is at rest want to be at rest only. Body which is in uniform motion want to be in uniform motion only. A passenger sitting in a bus, if a bus starts suddenly, passenger will move forward. And inertia at motion. Inertia at motion is body in uniform motion want to be in uniform motion only. If a car is moving or if a vehicle is moving, with uniform velocity, a passenger is standing. If this driver applies brakes, then the passenger will move forward. That means the body which is in uniform motion want to be in uniform motion only. Body which is at rest want to be at rest only. To change that state of rest or to change that uniform motion of the body, you have to apply some force. That is what first law says. And next is inertia of direction. Next one is inertia of direction. The body which is in one single direction, want to be in that direction only. So when body is moving in one direction, if you are taking a turn, the passengers who are sitting in that vehicle will bend. That is called inertia of direction. A cyclist who is taking turn will bend. A person who is moving in a circular track, a car which enters into a circular track will bend towards the center. That is because we are changing the direction. That's why body is not ready to change the direction. That's why it is bending. So these are all the examples. There are many examples regarding inertia at rest. We can remove dirt or dust from the blanket. By beating it with stick. You take a blanket, beat it with stick, dust can be removed. That is because of inertia at rest. Blanket is ready to move, but dust want to retain its position. That's why blanket and dust will be separated by the principle of inertia at rest. So first law of Newton defines a new physical quantity which is known as force. Force is the physical quantity which is responsible for the cause of motion. The cause of motion is force. And inertia we already studied. Then what is the measurement of inertia? How we will measure inertia? Mass is the measurement of inertia. If mass is more, inertia is more. If mass is less, inertia will be less. And next is Newton's second law. Newton's second law states that the net force acting on a body is equal to rate of change of momentum of that body. See, what is momentum? Momentum is a physical quantity which is the product of mass and velocity. Momentum is equal to mass into velocity, m into u, denoted by letter p. It is a vector quantity. So according to Newton's second law, net force acting on a body is equal to rate of change of momentum. That you can write F is equal to dmu by dt. This can also be written as dm by dt into u plus m into du by dt. Next, and one more formula you can write F is equal to m into v minus u by t, where v is the final velocity, u is the initial velocity. That means final momentum minus initial momentum by time taken. Pf minus Pi by time taken. And one more formula will be F is equal to m into a. That means it indicates that body accelerates in the direction of net force. Suppose if a body is pulled by two forces, this is F1, this is F2. Consider if F2 is greater than F1, body moves in this direction with an acceleration a. In that case, you have to write F2 minus F1 is equal to a. sorry ma. That means body always accelerates in the direction of net force. And one more formula also you can write, F is equal to m into v minus u, v square minus u square by 2s. This is another formula for force. So force is having many formulas. And next, types of forces. If you take types of forces, many types of forces are there. In second year you will come across electric force, gravitational force, and magnetic force, electromagnetic force. But here in mechanics we will think about tension. We have to discuss about tension, normal reaction. Normal reaction. Tension is the force developed in strings. It is developed in strings. And normal reaction is a type of contact force. It is a type of contact force in which one body is placed on another body. If the force which is acting perpendicular to lower surface of upper body is called normal reaction. mg will be acting down, and this normal reaction will balance this mg. Okay. And next is Newton's third law. Newton's third law is very familiar to you. Newton's third law is very familiar to you. Newton's third law states that every action has equal and opposite reaction. As equal and opposite reaction. Equal and opposite reaction. And this action reaction pair, forces will always occur in pair. Forces always occur in pairs. Always occur in pairs. Forces, action and reaction will be acting on different bodies, so therefore they will not cancel each other. So these are the concepts regarding the Newton's laws, and based on Newton's laws many applications are there. Now we will see the weight of the person in a moving lift. Apparent weight of the person in a moving lift. Weight is measured as the normal reaction what you are exerting on the ground. So when a lift is moving upwards with an acceleration a, what is the weight of the person? When lift is moving upwards with an acceleration a person of mass m is standing. So when lift is moving upwards, there is a contact between him and the floor, therefore there exists a normal reaction in this direction, and mg will be acting in this direction. And already I told Newton's second law states that body always accelerates in the direction of net force. That means here two forces are acting on the body. If you isolate the body from the system and write the write the forces on the body, that is mg and n. This type of diagram is called free body diagram. Free body diagram. It is a diagram in which free body diagram is a diagram in which the body is isolated from the system and various forces acting on that body, if they have written, it is called free body diagram. So if I draw free body diagram for this man, mg is acting downwards, normal direction is acting upwards, and body is accelerating in this direction. According to Newton's second law, body accelerates always in the direction of net force. That means it is accelerating upwards, means n must be greater than mg. So n minus mg is equal to ma. So n is equal to m into g plus a. This is the apparent weight of the person. The weight of the person who is moving upwards in a lift will increase. Therefore n is equal to m into g plus a. Next, consider the lift moving down. Next, consider the lift moving down. When lift is moving downwards, same case you consider. Draw the free body diagram of man. So if you draw free body diagram, this is mg, this is n, then this is the acceleration. So in this case, what you can write, mg minus n is equal to ma. Therefore, n is equal to m into g minus a. So weight of the person is more when he is moving upwards in a lift. Weight of the person decreases when he is moving downwards in a lift. Suppose if lift is moving up with constant velocity, then weight of the person remains same. When it is moving with constant velocity, acceleration of the lift will be 0. Therefore, mg minus n will be equal to 0. mg is equal to n. Similarly, if a lift is falling down freely falling lift, in case of freely falling lift, weight of the person will be equal to 0. Person will feel weightlessness when the lift is falling freely. That means m into g minus a, you have to take g, m into g minus g, because the acceleration of a freely falling body is equal to g. Therefore, normal reaction will become equal to 0. A person feels weightlessness inside a freely falling lift. So these are the concepts of Newton's second law, and this is one of the applications. There are many applications to be discussed in Newton's second law. That applications we will see in our next class. Thank you everyone for joining me.